lectures, and I think in my video lectures I have tell you most of the story and explanation about each of the slide. And for this session, I would like to talk about something more focused, right? And then this is actually today we're supposed to discuss about learning unit number 2, which is network model. So for these network models, we have two different types. We have two different actually models that we are talking about here. One is the OSI 7 layers. OSI a reference model. The name already tell you it's a reference model, so it is not actual model, but it's supposed to tell you that supposedly for a network model you should have 7 layers. So layer 1 is what, layer 2 is what, layer 3 is what, so on until layer 7. So and then each of the more importantly is actually each of the layers should have its own functionality, it has its own role, and then how does it how does it treat the data along when the data is being passed to that particular layer, right? So this network model is basically telling us that how our data is being treated, okay, before our data can be sent into the network, the physical network itself, right? So we have 7 layers. So your data coming from layer number 7, which is the application. So you have to use your software application to generate your data, right? If you are going to send an email, you must at least have an email client, right? But you may argue that I'm not using email client, I'm using webmail. Yeah, exactly. Yeah, your webmail, your browser, they're loading your webmail. That is actually the application. Okay, that's actually at the application layer. So once you have typed your message, you see that is your data that you want to send into the network to your friends. So your data is going to pass from layer number 7 to layer number 6. So number 5, number 4, number 3, number 2, number 1. Then when it's entered layer number 1, it will actually, going into the physical network, right? So it will actually travel through multiple network devices in the network until it will actually reach the destination device. So there's a whole concept of it. So this is something like when you're sending a letter, okay? When you send a letter to someone, okay? When you send a letter to someone, then your letter will have to be, put on a paper, put into an envelope. Then you bring it to your, courier service. Then the courier service got their own envelope again. So you have to put your thing into the courier service envelope. Then the courier service is going to send it through. Okay, so when your friends receive it, so it's actually a reverse process, right? A real process, like your friend will have to take off some of this packaging until it can actually see the letter. So this is exactly what happened in our network. So we have supposedly your data should be treated 7 layers, but today's our networks is actually very much based on TCP/IP, which is actually the internet. The internet is actually the network that you use a lot. So we are based on the TCP/IP model, which is actually referencing to the OSI 7 layers lah. They are very much similar to the OSI 7 layers. It's just that they do not have as many layers as the OSI 7 layers. It has only 5 layers. So you have application layer, then you go to transport layer, you go to network layer, you go to data link layer, and then physical layer. And then you go to the reverse again. So the TCP/IP model is the actual network model. The OSI 7 layer is just a reference model. Okay, it's just for referencing. So if you different network can actually adopt different network models. So today's the most popular one is the TCP/IP network model, which is actually what the internet is based on. Okay, so we will talk a little bit more about those things. So I will share my slide. Okay, here I would like to highlight some of the concept. Some of the concept here is actually when you have a network. So basically, you are trying to send your data across. You move your data across a network. So you have 2 computers basically And these two computers are actually meant by two different persons. So computer is actually a tool that you use to generate and view your information. So you need to actually send them across the network. So then you will enter a network protocol stack. So the network protocol stack consists of, for example, the TCP/IP model. They will consist of the five layers. So here, this example here will telling you that there is actually an application layer, which is OSI 5 to 7 layers. Then you have TCP/IP layer 3 and 4, and then you have an Ethernet layer, which is layer 1 and 2. So your data are going from the application layer all the way to the TCP/IP to the Ethernet. Then you go to the physical cable, which is actually this arrow indicate a physical cable connection. Physical connection, actually something you can see. And then you enter the receiver computer. At the receiver computer, you have this Ethernet layer, and you have the TCP/IP go up to the application layer, and then your data will be actually being recover. So you can see the original data that this host A is actually sending. Host A is sending to host B. So this is actually the entire process here. So I would like you to get this concept very, very clear. So data need to be treated. They cannot just send like that. To the user, you see that you type any ABC, any alphabet, then you think that you just send them across. But this alphabet are actually going through a series of process before they can be sent. So you must actually package them nicely before your data can travel across a network. Otherwise, they won't survive. Otherwise, people don't know this data belongs to who, this data sent to who, because there are so many network users, there are so many network nodes in the network. So you never know that where is this data should be sent to. Everything will be in a mess, right? So you imagine this network is actually something like a postal system. Okay, our postal system means that you need to have proper packaging. You need to write the address in a certain format. You need to have barcode for identification and blah blah blah, all those things, so that your packets can be delivered successfully to the right destination. Okay, so that you won't get lost. So exactly what happened here is actually this. So we have 7 layers, right? So I think they can be categorized into 3 general layers, which is actually the application layer, and then the TCP/IP layers, and then the Ethernet layer. So the Ethernet is very much the hardware, and then the TCP/IP is actually the language, and then the application layer is actually for data generation, data representation, data formatting. Okay? So if you want to have your format your data, so they're all happening in the application layer. Then later, when it comes down to the TCP/IP layers, they will be given an address. They will have to write address into your packet. Okay, the data that you want to send, they put address there. I'll put all the control and address all at the TCP/IP layer, and then later pass down to the Ethernet. The Ethernet is actually the hardware. You see, it's actually the hardware itself already. So when it comes to the hardware, how can your data be sent by the hardware? How your data is being sent by the hardware? How? In what format? In electrical signal, right? Only electrical signal has been used to actually send your message. So how is your message being represented by the electrical signal? So all these things are being handled by the Ethernet layer 1 and layer 2. That's why I will say layer 1 and layer 2 is probably the most complicated, because you have to convert your 1 and 0. Your data in alphabet, ABC, right? You understand ABC, you don't understand 1 and 0. But the computer understands 1 and 0 only. So when you actually type a message, so your message in alphabet will be first convert to 1 and 0. So this 1 and 0, because they all come in 1 and 0, then you don't know, how do you manage the 1 and 0? That's why you have to package them into groups. Okay? Group of 1 and 0. Then you have to put label, or this group is what, put the address and all those things. So you package them. So until you pass it down to the Ethernet layer, then the Ethernet layer will have to convert them into electrical signal. So how is 1 and 0 being converted into electrical signal? Okay, so we have different technique here. It's all defined in the Ethernet layers. So depending on the type of medium you are using, what I mean here is actually depending on the type of cable you are using. So if you are using electrical cable, so you are using electrical signal to represent your 1 and 0 so that you will send across the cable. So if you are using optical fiber, then you will be using the light. You see, optical fiber carry light. They use lights to carry your data, and then you will send using light. So if it is a wireless connection, okay, I mean all of you are actually quite familiar with wireless connection, your Wi-Fi, your mobile data, all these are wireless connections. So your data will be, converted into wireless radio frequency signal, so that it can actually travel over the air. So this is exactly what happened. And then over the other end, which is actually when it's arrived at the receiver. Of course, in between, it is not just one cable connect to another computers. A network is huge. There are a lot of intermediate network devices that will actually handle your data. Just like your data has been passed around, passed into different hands. Different people is going to look at your data packets and then try to say, okay, this data packet is for who? So all the intermediate network devices such as switches, such as routers, so they will look at your data packet and then they will decide, where to further send your data into the network. So they will do routing, people call it, or switching. They will do switching and they will do routing of your data packets so that at the end of the day, your data will be passed to the correct receiver, right? So these are actually the process. So the internet has consists of billions of nodes. So and then there's so much data floating around inside the internet. So you just have to have a mechanism. So this mechanism has to be follow accordingly, so that your data will not be lost, right? So that is actually the beauty of the network, and this is actually the entire what we call the protocol stack, which is actually making reference to the OSI 7 layers. So each of the layer has got different functionality, and for you will need to know the functionality of each of the layers, right? This layer doing what, what are the things that they did to the data packets and all those things. So you need to be clear. So once you are clear, then you know that, how they works, how the data is being passed from one layer to another layer, and what has been happening. And if you look at this diagram here, you look at this diagram here, we will have dividing the layers into two sections here. On the left, they're going to have one is the media layer. The media layer covers the physical data link and network. So this one is considered very much related to the hardware, the media. And the host layer is very much on something like the software. So you have application, presentation, session, and transport. And you can see the data unit here that they refer at each of the layer is different, you see. At the higher layers here, application, presentation, and session, they're all called data, right? So the moment when they enter layer number 4, the data is actually being called a segment. And then when they enter layer number 3, the data is being called a packet. When they are in layer number 2, the data is called a frame. And then when they are in the physical layer, the data is called a bit. Okay, so bit is 1 and 0 bit. And if you look over intermediate here, so the bits, the physical layer refer to the hardware layer. So second layer is basically link, network, transport, application. Okay, and the example is very important that you actually link them to the example. So the technology associated to the hardware one is based on the Ethernet standard. So you will have the Ethernet driver, which is actually the software driver for the hardware. You all know that all the hardware in a computer system, you will need to have a driver. So for networks, it's actually for network, for Ethernet, it is just another piece of hardware that you install in your computer system. So some computers do not have network interface. That's why they cannot be connected to the network. But today, all the computer has got a network interface. It's because a network has become so popular. So people will, by default, include a network hardware in your computer system. But if you talk about 20 years ago, when you buy a computer, your computer do not have a network interface. They do not have the network interface hardware. So what you can do is you go to the shop, you buy a network adapter, a network card, and you buy the network card, then you plug into your computer system, then your computer system will have that network hardware, okay, which is actually the Ethernet. Then after you install that piece of hardware, then you need to install the driver. If you do not install the driver, then your network adapter will never be able to work, okay, and your operating system will not be able to recognize your network interface. So you have to install a driver. After you install the driver, that is not good enough. You still cannot connect, you see. You still cannot connect to the internet. And you need to install the network protocol. The network protocol that you need to install is actually the TCP/IP protocol. And this TCP/IP protocol is also a piece of software. It's actually a network software. We call it a network protocol. It's something like another piece of software that you have to install. Once you have installed TCP/IP, meaning to say that this TCP/IP will actually bind. It will actually bind together with your network hardware. So that this is actually the TCP/IP is the language that you will be using when you communicate with other network nodes in the network. Then you have to install software as well. You need to have, for example, the most simple one is actually the internet browser. So you need to install the internet browser software, and your internet browser software, in order for you to exchange information, you are using the HTTP protocol. This is Hypertext Transfer Protocol, which is actually used in the World Wide Web. Look at the URL, the address that you are typing when you open up your browser. You always started with HTTP. You see. When you put a HTTP in front, meaning to say that you are going to use this protocol as a standard for you to communicate. See. So that's why you type the HTTP right in front of your URL address, your web address, for example, unimas.my, you see. And then there will be based on this TCP/IP protocol, and then based on this Ethernet, this network hardware called the Ethernet. There are so many different types of network hardware. Ethernet is just one of it, right? Ethernet is just one of it, and Ethernet is the popular one. Okay, so what you see here now is actually you are only seeing the popular one. In fact, there are actually many different types of network hardware other than Ethernet. You can have token ring, you can have FDDI, okay? All the different hardware. You can have ATM, okay? You can have, this Ethernet can be wireless as well, okay? It can be a wireless LAN, okay? So Ethernet is just one type of the network hardware. And then TCP/IP is also one type of the network protocol. Just one type, one of the type. There are so many different types of network protocol around, and just that today, because of internet has become so popular, that's why everyone is using TCP/IP. But during my time, okay, when internet was not so popular yet, we have many options of choosing network protocol. We can use Novell NetWare, we can use NetBIOS, you see. So all the different others protocol we can use to associate with our Ethernet hardware. You see. But for internet, if you want to be part of the internet, you have no choice. You have to use TCP/IP. And then because internet becomes so popular, so everyone now is using TCP/IP. People forget about Novell NetWare. People forget about NetBIOS. People don't care because those protocols would not allow you to connect to the internet. To connect to the internet, remember, for computer to be able to speak the same language so that they can actually communicate with each other, isn't it? And because of that, the internet speak TCP/IP. So if you want to be part of the internet, your computer must be also speaking TCP/IP. That's why TCP/IP now becomes so popular, and it becomes so popular for so many years, and then until other people have already forgotten about, the existence of other network protocol. And that's not important anymore. Things come and go, right? The one popular one continue to survive. The one that is less popular will die off. So same thing happened to technology, right? So, and then there are other technologies at the hardware layer other than Ethernet. We will have token ring, we have token bus, okay? All those technology has become less popular because Ethernet is good, high performance, and then they can offer they are cheap enough that they will be able to actually, give you all you want, and then furthermore, they got a different version. They got Ethernet, which is running at 10 megabit per second in the early days. Then later they upgrade to 100 megabit per second, become fast Ethernet. Then now they become gigabit Ethernet. Okay, gigabit Ethernet, they can run at 1 gigabit per second. And then now we will have 10 gigabit Ethernet, right? And so on and so forth. That's why Ethernet has become so popular as what we call the local area network technology that we use everywhere to actually allow us to connect to the internet. Okay, so those are basically just basic network architecture. Okay, basic network technology. Okay, these are actually the network hardware. These are all in layer 1 and layer 2. So what you see here is actually the first one is actually your network cable. This is actually a network UTP cable. So this is how it looks like. So I think it's very easy for you to look around and then find one of it. Okay, find one of the cable here. And this is actually the transmission media. And this other media is called the UTP cable. I think you will see them everywhere. And this is in layer 1. Okay, this is in layer 1. And then you will see in the middle here, this is actually a network adapter. And then this is USB. So for example, your laptop or your computers do not have the network hardware, or your network hardware is broken. So you can easily add a new network hardware through your USB port. So you buy this USB network adapter, and you plug into your USB port, then immediately you will have a network's hardware. You will have a network interface here. Okay, so this is how easy that you can enable a new network interface. For example, your laptop, you already have some of the laptop only got a Wi-Fi interface. Wi-Fi interface is also a network interface, but sometimes you prefer to use a cable, but your laptop do not have a network interface for cable. So you can buy one of these USB one, plug in, then you will have another network interface for the UTP cable. Okay, so this is how easy it is. And this one is in layer 1 and layer 2. Okay, this network adapter cover layer 1 and layer 2. And if you look at this diagram over here, this is another network adapter for desktop PC. So if your desktop computer do not have a network interface, or if you are not happy with your current network interface, so you can always buy one new one. Okay, this is a network adapter card. You just plug in, then you install the software, and you will have a network port for you to actually plug in the UTP network media. Okay, this is on your computer itself. And then there are some of the devices that you use at home. So for example, this is actually the switch. So you want to interconnect more devices together. So you need to have a switch. So your switch consists of multiple Ethernet port. So you can plug this to any of the port, and then plug it to your computer's network interface. Then you are connecting to the switch already. So this is actually the close look of the switch, how it look like. So I want you to be able to see the hardware and then start to imagine what we are talking about here, about the 7 layers or about the 5 layers. So what you see in this diagram here is basically talking about layer 1 and layer 2 only. Okay, layer 1 is actually purely hardware. Then layer 2, they involve a little bit of software, because if you actually look at some of these network devices here, they cannot just work based on hardware. They have some intelligence as well. So it is actually the software which is in layer 2. Your layer 2 will come with some software that must work together with the hardware so that they can actually operate properly. Right. So what you see here, this adapter, layer 1, layer 2. This desktop adapter, also layer 1, layer 2. This is actually a switch, which is also layer 1 and layer 2. But your UTP cable here, this particular cable here, is only in layer 1. Layer 1 is something very physical, something you can see, something you can touch. Okay, But layer 1 and layer 2 must work together. Right? You have to work closely, work together so that for it to actually function properly. So usually they are not separatable. You cannot separate them just like a software. Okay, software you can choose. My computer, I want to install different software. You can. But for layer 1, layer 2, usually they couple together. They come together as well. So it's very hard for you to just separate them. Right? So this is exactly it. That's why I'm showing all this diagram to make you understand better. So that you can imagine, otherwise we're just showing all the, layer and layer, and you don't know what we are talking about, you see. So that is pretty bad. And then, this is the local area network. What is a local area network here? Okay, a local area network is actually the most basic network that you can form, that you can create. For example, if you have a computers and then if you have a home network, you want to create the most basic network, so you should at least have either a wireless, either a router or a switch. So this is actually the central point where all the network nodes or network terminal is going to connect to. You see. So once you have a switch, for example, this is not a router. Let's say this yellow piece is actually a switch. So you can use all the cable to connect to the switch. So everyone will be connected together. So then you form a network already. As simple as that. And for some of you who are preferring Wi-Fi, you say, oh, I'm connecting using wireless. I'm not using cable. Then you have to have a wireless router or a wireless access point, right, as your network equipment. Then you can get them to link together, okay, without a problem. So the whole idea is actually you are using network equipment such as switches, routers, access point to actually interlink all the different network nodes, and then to form a network. So if you want to connect to the internet, then your network's equipment, for example, this yellow piece is either a router or a switch or access point, must connect to a gateway. Okay, you look at this broadband modem here, it's actually a gateway to the internet. So when you connect to the gateway, the internet gateway, then you will be part of the internet network. So whatever data that you send, it can go through all the network equipment from your network switches or routers all the way to your network gateway, such as the modem, and all the way to other networks within the internet itself. Right? So this is exactly what happened. So if you look at the diagram below here, I think for some of you who do have your own, what we call the for example, Unify, Maxis Fiber, then you will have devices like this, where you have a device with all the cable connecting together, and as well as you will have a device with an antenna, which offer you wireless interface. So this is actually the single device that allow you to connect all the device together. This is actually an all-in-one device. All-in-one means what? It combines switches, router, and wireless together, as well as your modem together, so that you can have all the functionality in one piece of equipment. And then you will be able to create a network through this device alone. And then this device will be able to connect you directly to the internet. Right. So I hope by showing you diagram like this will be able to ring you a bell, because you need to relate what you have in your daily life, what you have seen. You have to see it to believe it. So you have experienced network. So now we are trying to match your experience with the theory. Our theory here, we consist of 7 layers. Okay. So all the 7 layers all lying around within the network. Layer 7 lie inside your computers, which is actually the software that you are using to browse the network. For example, your web browser, your email client. What is an email client? Like your Outlook. If you install a software called Outlook, then Outlook is an email client. For some of you using Thunderbird, okay, Thunderbird itself is an email client, right? So, but some of you like to use webmail, so you are using browser. You are using your browser to act as an email client. It's a client software, it's just another piece of software, right? And then going down to your operating system. You know that your software must run on the operating system, isn't it? So you have operating system like Windows, like Linux, like your Mac OS. So you run on the operating system. Your operating system is going to have some of these networks software installed together. For example, they will have like your TCP/IP protocol, which is all handled by the operating system. And then your operating system also handle the hardware driver for your network adapter, for your network card, right? You have a network card, isn't it? Network interface is a hardware. So you must have the driver. So this driver is actually a piece of software that will interface your network hardware to the operating system. So your operating system basically handle the network protocol, which is TCP/IP, and then it will also handle the device driver for your network hardware. Then when come down to the hardware, it's actually the physical hardware lah. You have to install that hardware into your computers. Then that particular network interface hardware will connect a cable or either wireless. Okay, so they will be creating, participating in the network already. So I would like you to see, what you have, so that you can understand better what we are talking about here. What we're talking about here is actually not something abstract. It's something that you can see, right? So this is the whole idea of it. So I hope it is clear. But you have questions later, you can ask. And sorry. So I will go back to the 5 layers of TCP/IP again. So at the application layer, so it is actually, if you look at the example here, a host A talking to host B. Okay, host B is a web server. Host A is your web browser. For example, host B web server is our Ellipse server. Our Ellipse server is actually a web server. And then the web browser, our host A here, you are using a web browser to access our Ellipse, isn't it? So either you are using Chrome, you are using Firefox, Safari, Microsoft Edge. So those are actually the web browser. So your web browser is actually at the application layer. And the web server is also a piece of software. It's a piece of software such as Apache, such as Microsoft information IIS server. So those are actually the software as well, or at the application layer. But in order for this data to be able to deliver from host A to host B, you must go through, you must go down to layer 4, layer 3, layer 2, layer 1, then go all the way, okay? And then you go up again to from layer 1 to 2, 3, 4, and then go back to the web server. So for the data to actually appear. So this is exactly what it should be happening. Okay, so when your data from the web browser, you send a request. So your request will be going down to the TCP layer. Okay, so the TCP layer will actually basically establishing connection to the host. Okay, later we will see the details lah. Because each of the layer here we actually cover at the different learning unit here. Here we want to talk about something general. Okay, here we'll talk about something general about all the general layers, what they are doing. Right. So basically it has been passed down. So layer 4 is to establish connection. Then you pass down to layer 3. Then they will actually put a virtual address onto your data packet. So your packet now is being labeled with address. See. Okay. So pass down again. Then the data link layer, they will also give you another set of different address. And then this address only the computers understand. See. Okay. This is even lower layer address. So they have 2 different set of address here we are talking about. So different layer, they give you different address. Okay, different formatting of address. Then later pass down to the what we call the physical layer. So at the physical layer, this is the actual the communication service happening. So your 1 and 0, your bits will be transmitted all the way through transmission medium or transmission media. To the destination hardware. Then you do the reverse process, and going up, then your request will be arrived at the web server. So when the web server responded to your request, they're going to do the same by sending the data that you need. They pass down to layer 4 as well, from 5 to 4, 4 to 3, 3 to 2, 2 to 1, then send into a reverse direction. Then you go back to host A, web server, web browser. Okay, so this is exactly what is actually happening. That's why you will have to understand this, okay, this concept. And this is actually what happened to your data actually. So when you wanted to download a web page, for example, you wanted to download a web page here. Let's see. Okay. So if you are at the application layer here, so you want to download a web page, okay, from this address. So you pass your message down. So your message is you want to download, okay, a web page. This layer number 4 is going to add another header here, okay, to telling you that, okay, now you're operating at the source port here. Your destination should be port 80, okay? So they will add some additional information to your request so that they can identify what kind of service is that. Then when you further pass down again to the network layer, so they will add the source and destination address, okay? And then on top of what you have here, this whole thing is passed down. This whole thing here is passed down from the higher layer. And this whole thing is passed down from the higher layer, and then now they add an extra here. Then they pass down further down to data link layer. You can see this whole thing here is being passed down from upper layer. And then they add extra source MAC address, okay, MAC address here. That's why at every layers, they're going to add on some additional information, okay, so that the entire transmission process can be carried out. Then once this is done, then they'll send it to the physical layer. Physical layer basically convert everything into 1 and 0, from 1 and 0 into electrical signal. Okay, they have to convert 1 and 0, 1, 0, 1, 1, 1, 1 something, all this 1 and 0, convert them into electrical signal so that only electrical signal can travel across cable, isn't it? So your 1 and 0 is just a value. They do not have the characteristic to travel across a cable. A cable is used because this cable conduct electricity. So we are using electricity to send our 1 and 0. And all this conversion is all done at the physical layer. Okay, so this is exactly what happened. And again, we look at different layers. Each of the layer will have their own protocol, right? TCP/IP is actually, TCP belongs to one layer, IP belongs to another layer. Okay, so at the layer 4, for example, we always talk about TCP/IP, right? But there's another protocol called the UDP. So this, you can either choose TCP or UDP, depending on your application. Most of the time you are using TCP, but certain time you are using UDP, depending on your application. For example, when you are doing online transaction with your bank, whereas you are sending email, then you are using TCP. But when you are watching your YouTube and other stuff, then you are using UDP. But they all partner together with IP. See, so IP is actually Internet Protocol that is actually belongs to layer number 3. So layer number 4 has got their own protocol. Layer number 3 got their own protocol. And then layer number 5 also got their own protocol. For example, HTTP. HTTP is a application layer protocol, and then SMTP. SMTP is a small mail transfer protocol. It's actually used for your email, for you to send email. So when you're sending email, you are using SMTP. And then, of course, there are many others protocol around, right? That's why I would say here, I would like to highlight that different layers, you will have different protocol exist in different layers. And when you come down from layer 3 to layer 2, so you will have the network technology, which is actually Ethernet. And then, of course, Wi-Fi is a different type of data link. And then when you go down to the physical layer, there are different standards. 10BASE-T is actually the Ethernet. 10BASE-T and Ethernet is together. These two is actually together. And then your Wi-Fi and this 802.11 is together as well. So these are actually together. That's why you can see that at different layer, they will have different protocol, different standard. And they also use different name for their data unit. So how do you call the data unit in the physical layer? This is called a bit. Then if you go up to layer 2, they always call all this data unit as frame. Okay, how many frame are you sending? Then when you go up to layer number 3, people address them as packet. That's why different names are used in different layers. And then when you go up to number 4, it's actually used as segment or use datagram. So layer number 5, they call all this data as messages, right? So addressing, you can see the addressing here. Layer number 4 is using port number as the address. And then for layer number 3, they use IP address. Then go down to the data layer, they use MAC address. And the physical layer, they do not have address because those are all electrical signal that we are talking about. Okay? So I think from this table here, that's what I want you to be able to imagine. So we have to deal with different name of the data protocol unit, the data unit. They come in different names at different layers. As for the addressing, we have 3 different types of address in general. We have address happen in layer number 2, number 3, and number 4. Okay? So these are the 3 address that we commonly use if you talk about the internet. Okay, so I think our discussion from now on will be based on the internet because the internet is currently now the world's most popular network. And then all the other network has been abandoned. People not interested. So people only care about TCP/IP network. That's why this is actually specifically the TCP/IP network. So we have 3 different types of address in different layers. Layer number 2 is MAC address. Layer number 3 is IP address. Layer number 4 is port numbers. Okay, so they are using different port number for different services. For example, if you talk about if you want to access the web, then your port number is 80, 80. So if you want to talk about your, for example, your SMTP port number, I think is 110. Okay, so if you are using Telnet 23, if you are using secure HTTP, then your port number is 443. Okay? So these are actually different port number, different IP addresses, different MAC addresses. So whenever you encounter all this name, I don't want you to get confused. Right? I don't want you to get confused because when you get confused about all these things, it's so messy, you don't even know where you are. So those are actually the problems. Okay? That's what I say. By looking at this diagram here, I hope it will make things clear for you so that you know exactly what we are talking about when we talk about IP address. When we talk about IP address, we are definitely talking about layer 3, right? If you talk about MAC address, we are definitely talking about switches, layer 2, okay? All the network adapter has got their own MAC address. All the switches has got their own MAC address. In fact, every network port has got their own unique MAC address. So the MAC address is actually unique and you cannot change it, you see. MAC address you cannot change. Usually by right you cannot change. But for the pros, they will know how to change. Usually this MAC address here is what we call the hardware address. So it's come together with the hardware. But IP address you can simply change. Every time you start your computers, you might get a different IP address. So IP address is quite common there. I think you can change that. But the port number is kind of dedicated because if you want to offer a service in the internet, you want to run a server, right? So you have to stick to the standard. So which port number is used for what type of service? So if you are hosting that kind of service, for example, if you host a web server, okay, you are hosting a website, so your port number is always port 80, port 80. So it's go by different service, different port number, right? So I hope you can get a clear pictures about this one. So I actually put out all the different names here. So you're going to see this name in our future learning unit. That you will see, what is packet, what is a frame, what is a bit, and all those things. What is IP address, what is MAC address, what is port number, okay? And then so on. Right. So I hope this is actually going to keep the whole thing going. So yeah, I would like to take questions. So, do you have any questions? See, where's my... Yeah. So any question? Because the whole idea here is about the layers, different layers come in. This is about the general concept of the layer itself. So your data will have to go through all the layers, depending on the models lah. If you are using TCP/IP, then your data will have to go through 5 layers before it can enter the network. Once enter the network, then once it is actually arrived at the destination, then you will actually, go from layer 1 to layer 5. Right. So TCP/IP model is just one of the many network model. Yeah. You have questions? You might ask. I think this is the time. If you have anything that is confusing, if it's not, then that is very good, right? And I already put up the new tutorial question for learning unit number 2. So far, I haven't seen anyone responded yet. So I think right after this, you can actually take a look at our new tutorial question in the forum, and then you can try to answer some of these questions. I think answering question is good because sometimes you think that you know, but the moment when you see the question, then you start to realize that, oh, actually, I don't know. See, so the question can act as something to wake you up, okay, from your dream. Sometimes we actually think that we know everything, but in fact we don't. So make use of the tutorial questions to ring your bell. So if you look at the question and you don't know, that means that you might have been missing some understanding. You might go through the thing, but you are not yet fully understand. Right? Okay, so everything all right? And I think this week, once we have finalized the assignment, so our assignment will release sometime this week. And I will actually group you into a different group. This is going to be a group assignment. Unfortunately, you cannot choose your group, I will choose it for you. Please don't complain yet, see, because the whole reason behind this is that I want you to meet stranger. I want you to be able to improve your interpersonal skill. Because next time when you enter the workforce, when you join a company, can you choose your colleague? I don't like that guy, I hate that guy. Can you ask the boss to fire that guy? You cannot, you see. You like it or not, you have to work with the guy, you see. So this is the whole idea of I just try to put you into strangers group. That you have to work with different strangers, and then this is also a very good experience that you can make new friends. At the same time, you have to handle your group in such a way that all of you adhere to the same direction to produce the best for your assignment. I know there will be some members are actually problematic, but I think there is a challenge. Next time when you join a company, there might be some employees are problematic. It could be your immediate supervisor as well, which is problematic. So how are you going to deal with it? Are you going to quit the job? You see, so those are actually very practical questions. And then when you and some of your colleagues were put together to handle a project for the company, so are you going to say that, oh, that guy didn't do his job, that's why we couldn't, produce the things at the end of the day? So do you think your boss is going to buy that for all those excuses and that, okay, because that that person do not do the job and all those things, that's why the whole thing failed and things like that? So it is unacceptable. So that's why I say you have to put yourself in a shoes that where you are now joining a company, and this company you cannot choose who are your partner. So you have been assigned to work with different partners, and how do you make things to work? So that is also one of the very important skills that you should be picking up during your university day. Even though now you are doing it online, but there are many ways to communicate to get things sorted, right? So sharpen your skill. So we are giving you the opportunity to sharpen your skill. So I will choose your group member for your group assignment. But for group assignment, please, once it is available, I will inform again. And please do not miss the submission. If you miss the submission, then you're going to lose the marks for your assessment for this course. And do not pass the deadline. It's good to submit 1 or 2 days before, because when the system say cannot submit, then there is cannot submit lah. Because it is not me stopping you, but it is the system. The system, you cannot talk the system down. The system is just a dummy computers following instruction, right? So make sure you keep the deadline, and you work together in a team with all your members, and you discuss about how to produce the best ever assignment for this course, and win the mark. All right. So I think this is actually what you should be doing to this, and I'm going to put you into groups once the grouping list is out. So you need to again do your own discussion and figure out your group assignment. All right. So is there any question? Any further question? If there is none, then I would suggest you now, you should after our session ended, you should go to Ellipse and look at our tutorial question. Try to participate in our tutorial. This is just a few questions that you try to answer, and then the more important thing is that when you look at your friend's answer and all those things. I also gave some comment for the previous tutorial as well. Tutorial 1, I also gave some comment for some of the question, so you also can take a look. So this is actually where interactions come into the pictures. So through the online tutorial, I hope you can actually gain better understanding of the topic that we cover. And also for next week, the video lectures is also ready, and the lecture slides also ready. So I will need you to go through them tomorrow. You see, tomorrow we have another 2 hours, right, for this course. That is the time where you go through your video lectures, right? That's why I say, I'm giving you time for all these things, so it is not overwhelming. All right. Any other questions? If no question, then I will show you the attendance again. Show the attendance again. For those who haven't taken your attendance, you can take your attendance now. And if you have done your attendance, I think you may leave, and then you can head towards the Ellipse for the tutorial to answer some tutorial questions. Okay, if you have done your attendance, you may leave, and then you can go to Ellipse.